We will now find the particular antiderivative of this given function, that is f of x equals e power x times of 1 minus 2 power x, and the graph passes through the point 0, 1. So basically this f of x represents a derivative of some function, which means we have to find the integral of this function. So let me put this as integral of f of x. So this is equal to integral of e raised to the power of x times of 1 minus 2 raised to the power of x. Then we put this dx. Since this f of x here is a derivative of some function, and if we integrate it, we will get the original function. That means we will get the function as y. So integration of f of x, I'm going to write down this as y, and this equals, we have to basically integrate this one. So first I'm going to distribute this e power x into the bracket. We have 1 minus 2 power x. So let's do the distribution. When I do that, I get e power x times of 1 is e power x minus e power x times of 2 power x is 2 power x times of e power x. So this is what we have inside the integral. Now in the next step, we could split this into two integrals using the difference rule of integration. So I'm going to write down this as e power x dx minus integral of 2 power x e power x dx. Now we can consider this as two separate integrals. I'm going to consider this as integration 1, that is I1, and this I'm going to consider as integration 2. We are going to see how we can integrate these two integrals separately. So let's do the integration of the first integral. So maybe we call this equation as 1 because later on, once we have found the integral of I1 and I2, we will have to substitute into this equation. So first let me copy this I1. We have I1 equals integral of e power x dx. Notice that we can use the standard formula to integrate this e power x. Integration of exponential function, that is e power x, is e power x itself. So I'm going to write down this as e power x. I'm not writing the constant of integration here because once I have integrated both the integrals, I will put a constant later on. So let's have the result of I1 as e power x. So let's consider this as 2. Now we are going to find the integral of I2. That is, we have I2 equals integral of 2 power x e power x dx. To integrate this, we will have to use the integration by parts method. So I'm going to integrate this using integration by parts method. In this method, we will have to first follow the ILATE, that is ILATE rule, which actually stands for the inverse logarithmic, algebraic, trigonometric, and exponential function, to choose the variable u. So if we look at our function, we have this is 2 power x, and then we have this exponential function. So we can choose this as u because e power x, this is an exponential function which comes last, which means this 2 power x, this is a kind of exponential, but however we can consider this as an algebraic as well. So I'm going to consider this as u, and the remaining part, that is e power x dx, as dv. So let me do it. Before that, let me write down the integration by parts formula. The formula is integral of u dv equals uv minus integral of v du. So this is the formula that we are going to use. We have already selected the u. So let me write down the u. This is equal to 2 raised to the power of x. I just put a vertical line to separate. And then we have considered the dv equals e power x dx. So now in this part, that is here, we have to differentiate. That is du equals differentiation of 2 power x is using the derivative formula. This is 2 power x times of ln 2, and this side we have to integrate. So we integrate like this. Integration of dv is basically v, and integration of e power x is e power x. So now we have these values u, v, du, everything, which we can substitute into this formula. So basically we are finding the integral of I2, that is integral of 2 power x e power x dx, where we have chosen this as 2 power x as u, and the remaining part, that is e power x dx as dv. So basically we are finding this integral, so which means we can substitute into this formula. So first we have to write down uv, that is we have u here, which is 2 power x, and v is e power x. So therefore it is 2 power x e power x minus integral v du. We have v du here, so I put this e power x, and then in place of du we have 2 power x ln 2, and then we put this dx. In fact, we should have put dx over here. So this is what we get after we substitute into the formula. We will simplify this. This is equal to 2 power x e power x minus, basically we have natural logarithm of 2 over here. This is a constant. Natural logarithm of 2 is a constant which could be factored out of the integral. So I can write down this as natural logarithm of 2 times of 2 power x e power x dx. This side we have I2. So now if we look at this expression, that is the integral expression, this basically is our original I2. As you can see from here, I2 is basically integral of 2 power x e power x dx. So I can simply replace this as I2. So I'm going to replace this as I2. So we have natural logarithm of 2 multiplied with I2, and this side we already have I2. So now we have to solve for I2, which means I'm going to add this component to both sides. And when I do that, I will be getting I2 plus natural logarithm of 2 I2 equals 2 power x e power x. Now we factor out the I2 on the left side. So when I do that, I get 1 plus natural logarithm of 2 equals 2 power x e power x. So basically we have to solve for I2. So when we do that, we have to divide both sides by this component, that is this term, that is 1 plus natural logarithm of 2. And when we do that, we get I2 equals 2 power x e raised to the power of x divided by 1 plus natural logarithm of 2. So we have successfully found out the integral, that is integral of our second term in the equation number 1, which results in 2 power x e power x divided by 1 plus ln 2. So now I'm going to substitute into this I1, the result of I1 and I2 into our equation 1. So which means we will get the equation for y equals, let's go back and verify the I1. We have I1 equals e power x. So therefore I can substitute e power x, and in the equation number 1 we have negative after the integral of I1, and then integral of that is I2 we already found the result of I2, which is 2 power x e power x divided by 1 plus ln 2 natural logarithm of 2, and this time we put this constant of integration as c. So basically this is the antiderivative of our original function. And now since we want to find the particular antiderivative with the given condition that the graph passes through the point 0, 1, we'll utilize this condition to determine the value of c. So basically we have to plug in x equal to 0 and y equal to 1 into this equation to solve for c. So let's do that. So I'm going to plug in y equals 1. This means 1 equals e raised to the power of 0 times of 2 power 0 times of e power 0 divided by 1 plus ln2 plus c. Notice that e power 0 is basically 1. So this can be replaced as 1. As well as 2 power 0 is 1 and e power 0 is 1. So 1 times of 1 is basically 1. So I'm going to replace this quantity by 1. So I can cancel, I can subtract 1, which means I will be getting 0 equals negative of 1 by 1 plus ln2 plus c. And when we solve for c, we get the value of c equals 1 over 1 plus natural logarithm of 2. So to find the particular antiderivative, we have to substitute the value of c into this solution equation, that is into this equation. So let's do that. And when we do that, we get y equals e power x minus of 2 power x e power x 2 power x e power x divided by 1 plus natural logarithm of 2 plus the value of c, which is 1 by 1 plus natural logarithm of 2. So this is the particular antiderivative of this of the given function and passing through the point 0, 1.